Hi everyone, today we're going to learn about inverse function. We will learn how to find inverse of a function. First of all, let's see what is an inverse function. We know that if we have f of x, this f maps x to y. But inverse of function, which is called f negative 1, this negative 1 is not exponent, it's just a symbol that says this is inverse of f. So f negative 1 maps y to x. This means if a point like x and y is on the graph of f of x, then the point y and x will be on the graph of f negative 1. Therefore, the inverse of the graph of f of x will reflect over the line y equal to x. So what does this mean? For example, if I have a graph which is, let's say, like this is a point of my graph as x and y, and it's, let's say, 4 and 2. We want to find the inverse of this function. The inverse will be 2 and y because we switch x and y. F maps x to y and f negative 1 maps y to x, so f negative 1 will be 2 and 4. So it's going to be somewhere like this. Let's say if this was 4 and 2, now it's going to be 2 and 4, so it's going to be here. And this is actually a reflection over y equal to x. This is y equal to x. We know that if we have any point here on the other side of y equal to x, we can find a mirror of that point on the other side. So this means these 2 points are reflected over y equal to x. So f and f negative 1 are reflected over y equal to x because we just switch x and y's, and that gives us a reflection over y equal to x. Now let's say we have a table of f of x. We want to find the table of negative 1, f negative 1, which is the inverse function. All we need to do is to switch x and y. So instead of mapping 2 to 4, now f negative 1 is mapping 4 to 2. And here, instead of 3 to 6, this will be 6 to 3. 4 to 8 will be 8 to 4. So this is the table of f negative 1. Let's see how we can find the graph of an inverse function. Let's say this is our function, the graph of our function, which looks like y equal to x squared we want to find the inverse graph of this function, which is actually here already done, but I want to tell you how we find this. In order to find the inverse graph of a function, the best way is to find some major points. Like, for example, here this one is 2 and 4. This point is 1 and 1. This point is 0 and 0. And this one is negative 2 and 4. So these are the points on our f of x. Now we want to find f negative 1. All we need to do is to switch x and y. So 2 and 4 will be 4 and 2. And that's here, this point, 4 and 2. 1 and 1, if you switch x and y, it's not going to change. It's going to be the same thing, 1 and 1. 0 and 0 again the same way. It's going to be the same thing. And negative 2 and 4 will be 4 and negative 2, this point. And then we simply just connect the points to each other using the same pattern that we had on our original function. So this will be the graph of inverse function, like this. And if you notice, these two graphs are reflected over y equal to x. This line is y equal to x, and these two are reflected over y equal to x. Means whatever I have on this side, I have a mirror of that on the other side. This is how we can find that. For example, at this point, if you draw a straight line here, and then the same distance you go to the other side and you will see this point. So for each point you will see a mirror of that point on the other side of y equal to x. This means these two graphs are reflected over y equal to x. Now for this graph that you see here, we can easily find the inverse by finding some of the points. For example, this is 2 and 8. This one is 1 and 1, 0 and 0, -1 and -1, and this point is -2 and -8. Now in order to find the inverse of this graph, we just need to switch x and y. So if you switch x and y here, this will be 8 and 2, this point, 8 and 2. 1 and 1 is going to be on the same point, 0 and 0. If you switch x and y, nothing will change. -1 and -1, again the same thing. And -2 and -8 will be -8 and -2. So it will be here, -8 and -2. Then you just need to connect these lines together, these points together, based on the same pattern that you see on the original function. So it's going to be something like this. This will be the inverse graph of your function. Again, you will see that it's reflected over this line, which is y equal to x. Anything that you see on this side, you can see a mirror on the other side as well. Now, how do we find the inverse of a function like y equal to f of x algebraically? The rule is switch x and y, switch x and y, then solve for y. Now we're going to try that here. Okay, here let's start with part B first. It's easier than part A. So I'm going to start here. Y and x are here. I'm going to switch them first. X to the power of 3 equal to 1 over 2 y. Oh, I'm sorry, I made a mistake. Okay, we're back again. You switch x and y, so instead of y you're going to write x, and instead of x you're going to write y. So this is x equal to 1 over 2 y to the power of 3. Now we need to solve for y. That means you need to get the y by itself on one side. So you have to get rid of everything that you have around this y. The first one that we want to get rid of is this 1 over 2. So in order to cancel this 1 over 2, you can just multiply both sides by 2. So then 2 times 1 over 2, they cancel each other, and on the left side you have 2x equal to y cubed. Now you want to cancel the power of 3, so you take the cube root of both sides. You cancel the 3's, and what you have left is y equal to cube root of 2x. The last step is just to use the right notation. Instead of y equal to, we're going to write f negative 1 of x. F negative 1 of x is equal to cube root of 2x. So it's better if we use the right notation. If you just write y equal to, then that means just a normal function. But when you write f negative 1 of x, this means you have found the inverse function. This is inverse of another function. Now let's find the inverse of this function. We have f of x equal to 2x plus 1 over x minus 1. So first of all, let's change this to y. This is y equal to this, because we want to switch x and y. Then we start by switching x and y. So y will be x, equal to 2y plus 1 over y minus 1. Now our goal is to have the y by itself. So we're going to start from here. I'm going to put a 1 in the denominator because we know x to the x over 1 is the same as x. Now we can cross multiply these. By cross multiplying these two, this will be x times y minus 1. So you're multiplying this side, and then this is equal to 1 times 2y plus 1, which we know that 1 times anything is just the same thing, so we don't have to write the 1. It's going to be 2y plus 1. So we got rid of this fraction, but now we have two y's, one on this side, the other one on the other side. And this y is stuck here in parentheses. So we need to make this y free of this parentheses. We can distribute the x here. This will be xy minus x equal to 2y plus 1. Now I'm going to subtract 2y because I don't want the y be here. I want to move it here. So subtract 2y from both sides. This will go away, and it will be xy minus 2y minus x is equal to 1. Now let's get rid of this negative x. So add x to both sides. This will go away, and we will have xy minus 2y equal to 1 plus x. Okay, what we have right now is 2 y's on the left side. This is better than what we had before. Now we just need to have only one y. How do I get one y here? The best thing is to factor y from these two, because this y is in common between both of these two terms. So I factor the y out. It will be x. So from the first term, if you factor y, you will have only x left, and the second one, x minus 2, is equal to 1 plus x. Then if you just divide each side by this x minus 2, you can get rid of this parenthesis x minus 2 on this side and then have the y by itself. So these two will go away, and your y will be equal to 1 plus x over x minus 2. This is your function actually. You just need to use the right notation. F negative 1 of x, f negative 1 of x is equal to 1 plus x over x minus 2. So this is our inverse function. Okay, what is domain of f with respect to domain and range of f negative 1? Domain of f is always range of f negative 1, and range of f is domain of f negative 1. So how does this happen? Let's say we have a function like f which has these points 2 and 3, 4 and 5, 6 and 7. So these are the points that we have on our graph. The domain of this function is all the x values. These are the x values. So domain is 2, 4 and 6. What is my range here? Range is all the y values. Range is 3, 5 and 7. Now we want to find domain and range of negative 1. We know that if I have f negative 1, means inverse of this function, the inverse will be switch of x and y. So the inverse function has 3 and 2, 5 and 4, and 7 and 6. So this is our f negative 1. And let's find the domain and range of this function. Domain of f negative 1, again, will be all our x values. So these are the x values, which is 3, 5, and 7. What is range of f negative 1? All the y values. So there are 2, 4, and 6. Now if you notice, the domain of f is equal to range of f negative 1. They have the same values. And range of r is the domain of f negative 1. So domain of f is range of f negative 1. Range of f is domain of f negative 1. We switch the domains and ranges. Now we want to verify that inverse of a function like f of x equal to 1 over x minus 1 is this function, 1 over x plus 1. All we need to do here to verify two functions are inverse of each other is this. This is the rule. F of g of x equal to g of f of x. And they are both equal to x. This is what we need to prove in order to prove that two functions are inverse of each other. So we're going to start here. Start with f of g of x. F of g of x. What I'm going to do first is find the g of x and replace it here. What if my g of x is actually f negative 1? So let's call this g of f. So this is my g of f. F of 1 over x plus 1. This is my new x, which is going to replace for the x here in f of x. So f of x was supposed to be 1 over x minus 1. It was supposed to be an x here, but now my new x is this value, which is 1 over x plus 1. Now we can easily cancel this plus 1 and this negative 1, and we will have 1 over 1 over x. And we know that 1 over x is actually equal to x. So the left side now is equal to x. If you don't know how this happens, 1 over x equal to x, this is the explanation. If you have division of fractions, let's say a divided by b over c, you are going to keep the top and multiply by the flipped of the bottom. It's c over b. So here, if I have 1 over x, I'm going to keep the top and multiply by the flip of the bottom, which is, it was 1 over x, now it's x over 1. And that's equal to x, because 1 times x is 1, divided by 1 is x. 1 times x is x, divided by 1 is x. So the left side is equal to x. Now let's talk about the right side. G of f of x. F of x was 1 over x minus 1. So g is 1 over x minus 1. This is g of 1 over x minus 1. Now in my g, which was actually the f negative 1, the rule was 1 over x plus 1. It was supposed to be an x here, but now my new x is 1 over x minus 1. Okay, now let's first of all take care of this long fraction, like big fraction. 1 over 1 over x minus 1, like exactly what we did here, is equal to just x minus 1. So it's x minus 1. And then we had a plus 1 here. These ones cancel each other and it's equal to x. Now we see that both f of g and g of f are equal to x. That means f and g are inverse. Okay, in this problem we want to find the inverse of y equal to f of x equal to x squared. Let's first of all graph this function. We know that the graph of y equal to x squared looks like a parabola. It's something like this. It's something like this, a parabola. But here the problem is that we have only the x values greater than 1. Means the left side of the function, which is all the x values which are less than 1, are not included. So I can delete this part, take off this part of my graph, and this is the only function that I have. Now I want to find the inverse of this function. So let's say this is 2 and 4 on my y equal to x squared. This is 1 and 1, and this one is 0 and 0. To find the inverse, you just find the x and y which is switched. So it will be 4 and 2. Let's say this is 4 and 2. And 1 and 1, if you switch, is going to be the same. 0 and 0 again the same. So this will be the graph of inverse function. Now, if you want to find it algebraically, y equal to x squared, then you need to switch x and y, x equal to y squared, then you need to get the y by itself. So you have to get rid of this power of 2. So you take the square root of both sides. This will go away, and then you will have y equal to square root of x. Then we're going to use the right notation. f negative 1 of x is equal to square root of x. So this is the algebraic form or equation of f negative 1, but we also need to consider the x greater than or equal to 0 that we have here. This is the limit or restriction of the domain of my function. So here on the original function we had only x greater than 0, and the same is for our inverse function. The inverse is also all the x values which are greater than or equal to 0. So this whole thing is the inverse of our function. So this was today's lesson. Hope you learned well and practice more. Have a great day.